Section 5.3 is all about trigonometric graphs. The first graph we're going to inspect is y equals the cosine of x. And so, for different values of x, we want to figure out what does y look like. So here we have a table of values. We've got all of these possible x values, and we're going to figure out the y values based on what we know of the unit circle. So the cosine of 0, of course, that's 1. The cosine of pi over 4, if you remember, that is root 2 over 2. So take a minute and fill out the rest of these values. Press pause on the video. Did you get these values? I hope so. So now let's plot some points. Our first point is x is 0, y is 1. Next we have pi over 4 root 2 over 2. And so you'll want to approximate that. You can pull out your calculator, of course, root 2 over 2 and pi over 4. So root 2 over 2 is about 0.7 and a little bit more. So we'll just eyeball this one. Next we have pi over 2 at 0. Pi over 2, of course, is 0.05 pi, or 0.5 pi. And we just kind of continue on. And so our function, this graph, is going to kind of look like this sort of wave pattern. And if we were to continue that pattern, the graph of cosine of x kind of has this sort of, this wave-like pattern. Let's try the same now with the graph of y equals sine of x. So fill in the table above with different unit circle values. And after you filled in the table, start plotting these points. And when you smooth out the curve, you again see that telltale wave pattern. And if we continue the pattern, you'll see that the sine curve and the cosine curve really match each other quite well. You'll notice there's a little bit of shift, the red curve and the blue curve. And that's by design. That's kind of how sine and cosine relate to each other. And so that brings us to some vocabulary. We say that these functions, the sine function and the cosine function, are periodic. And by periodic we mean that the pattern repeats. The shortest pattern that repeats is called a cycle, and the length in terms of the x direction, the horizontal length, is called the period of the function. So the sine curve and the cosine curve each have a period of 2 pi, and so we would say the sine of that angle, the sine of rotation, is t plus or minus 2 pi versus cosine t plus or minus 2 pi. The domain of each function, of course, is all real numbers. The range in this case, kind of the high points and the low points of those waves, determine that the range is from -1 up to +1. Some additional definitions when it comes to sine and cosine graphs. Here we've got kind of our basic transformations of these graphs. A in these functions refers to the amplitude. In other words, the height of all the peaks and valleys that would form from a baseline. The amplitude is the absolute value of A. It's possible to have a negative amplitude, and in that case the graph would be reflected over the x-axis. The frequency, K, is how many times a cycle occurs in a domain of 2 pi. And so frequency and the period of the graph are related. The period is how long it takes for one cycle to fully complete itself. So frequency is number of cycles in 2 pi, and so then period is essentially how long it takes within 2 pi. So 2 pi divided by the absolute value of k. And note also that k up here could be outside of a set of parentheses, or it could be distributed in to those parentheses. Then we've talked about horizontal shift. In other words, the phase shift, which is based on k. We're moving kind of around left or right of b units. Note that if k has been factored out, then you can just talk about horizontal shift right away, but it's possible you might have to factor that k out. And then also we have our vertical shift, up or down c units. So we've got our c's typically out front, although you could find them anywhere around, but outside of those trigonometric functions. And so for our first example here, we have y equals -2 sine of x. And so that negative, that tells us that we're going to reflect over the x-axis. The fact that that value is 2, or at least 2 in absolute value, that tells us the amplitude is 2. In other words, how high are the peaks and valleys. If we rewrote this as -2 sine of 1 times x, that indicates that the frequency here, in other words, how often do we see a cycle, frequency is 1, and so that means the period is 2 pi. And so we don't have any horizontal shift, we don't have any vertical shift. And so all we have is our kind of our original graph, but reflected over the x-axis with an amplitude of 2. And so the sine function, remember the original sine function kind of looked like, let's see if I can draw it in. The original sine function sort of looked like this. And with our amplitude and reflection, we're still going to have that same sort of idea, but now instead of a peak at pi over 2, we're going to have a valley at pi over 2, and a peak at 3 pi over 2. So we see kind of that shape emerging. Should go all the way down there. So you kind of get the idea. Here, of course, is a better picture of what that graph ought to look like. With this next example, first we have an amplitude of 3. We have that coefficient next to the sine function. Then for a frequency, we see we'd have a frequency of 4, and what that means is that the period, in other words, there'd be how many cycles in one period, is going to be 2 pi over k, so 2 pi over 4, which gives us a period of pi over 2. And so the graph is going to cycle over every pi over 2. There's no horizontal shift, but there is a vertical shift. I see this plus 2 out front, and so we're going to go up 2. And so if we were to look at the kind of the original graph without the vertical shift, we have a sine graph, and so we're going to start at 0, 0. With that period of pi over 2, we know by the time we get to pi over 2, we're starting over in the graph. And so that indicates that we're going to reach our maximum and then go back down to a minimum within pi over 2 of a domain. However, that vertical shift tells me that everything is going to be shifted up too. And so instead of starting at the point 0, 0, we're going to start at the point 0, 2. We're going to end up at pi over 2 later. So go up 2, down, and end up there. So we can see our cycle as well. Oops, that should have gone down a little bit further, shouldn't it? Because of our amplitude of 3, that should reach above and below this kind of baseline based on the vertical shift. So up and below 3. Here's a better image of what I was talking about. We can see there is one full cycle that happens in pi over 2. So from this point to this point, in the x direction, that is just pi over 2. Maybe you want to try this example on your own. You can pause and try and fill in the information, and then unpause and continue on. First note, with that negative out front, we have a reflection in the x-axis. The coefficient of 4 indicates that the amplitude is 4. The frequency we see, the frequency is pi. And so the period here, remember 2 pi over frequency gives us the period, and so our period is 2. In other words, the graph is going to cycle over every 2 units in the x direction. We have no vertical or horizontal shift, and so with the cosine graph, the x starts off in a trough. In other words, we're going to start off down here at -4. The maximum is going to be reached and then back down to a minimum within 1 period. And so, kind of drew it poorly, but you kind of get the idea that this graph is going to cycle over and then back up. Oh my. Sorry, that's a poorly drawn graph. You kind of get the idea. And so you can see that our cycle happens not every pi units, not every pi over 2 units, but every 2 units is our period. With this next example, again, feel free to pause the video and try it out in your own. We have an amplitude of 3. Our frequency, note that the coefficient next to the x is inside the parentheses, and so we'll want to factor that out. If we factor it out, we were left with 2 times the quantity, x minus pi over 2. So we have a frequency of 2, which means we have a period of 2 pi over 2, so a period is pi, and we have a horizontal shift this time. Right? This fact here tells us that we have a horizontal shift of pi over 2 to the right. So to the right, pi over 2, and there's no vertical shift here. So the original function without that horizontal shift, we know with a cosine graph we were starting off remember, a cosine graph kind of starts off at the top of its, at a peak. And so we'd start off at 3, and within 1 period we're going to swoop all the way down to -3 and back up. So down here, back up. However, we're shifting to the right pi over 2. And so each of these points is going to shift over a couple of units. And so we have this graph where we have shifted everything over pi over 2. Here's kind of a better visual of what that's going to look like. Give this one a try on your own. We'll fill it in and take a look at the graph in just a sec. So without the horizontal and vertical shift, that's what our function would look like. But with the shift to the left pi and down 1, we know that this current point at 0, 3 is going to get shifted over and down. Likewise, the rest of the points are going to get shifted over and down, shifted over and down, And so we see our function looks something like that blue one there. And here it is with all the repeating cycles. To solve sine of x equals negative 0.6, the first thing we'll want to do is graph sine of x. Now let's adjust this interval a little bit. We're going to say from negative 2 pi up to positive 2 pi. And so remember, a sine graph starts at 0, 0, kind of swoops up, down through pi, back up to 2 pi, and the same is true, oops, Alright, so we want to find when sine of x equals negative 0.6. In other words, when does the y-coordinate of the graph equal negative 0.6? We see it happens in 4 different spots. And so for now, I think it's sufficient to graph the two functions y equals sine of x and y equals negative 0.6, and using the intersection feature on your calculator, we can find the x values that produce those intersections. Here we got 3.785 and 5.64. And let's take a look here. If we were asked to write the equation for this function, we see first of all the peaks and the valleys happen at 4 and negative 4, and that indicates that the amplitude here is 4. Remember, amplitude is the kind of the height of the peaks and valleys based on that baseline value. Next, our frequency. Frequency says how many cycles do we see within 2 pi. Well, from x is 0 over to 2 pi, I see there's 2 cycles, and so that means there's a frequency of 2. And remember, period is 2 pi over frequency, and so our period here is pi. And so that gives us a sine equation of y equals 4 sine of 2x. Now, a cosine function, a cosine graph, is essentially the same as a sine graph. It's just translated to the left or right. So we'll hold off on that for now. With this final example, we kind of want to figure out our amplitude. To do that, we need to figure out where is kind of the baseline measurement. Now, that baseline measurement would be right here, is sort of the middle of the peak and valley. And so my amplitude here, I see, is up 2, down 2. So I have an amplitude of 2. Next, for a frequency, I see that the cycle repeats itself after, oh my goodness, from negative 2 pi over to pi. And so within 2 pi, I see there's a frequency of 1/2. I only have half of a cycle occurring, which indicates that the period of this function is 4 pi. To think about horizontal shift, if you remember, the cosine function begins at the top of a cycle. And so this difference here I see is negative 2 pi. And so if we talk about a horizontal shift, we could say left 2 pi. And we had that vertical shift of positive 1. So we'd say we'd have vertical shift of up 1. And so if we're strictly talking about a cosine function, we have a vertical shift up 1. Our amplitude is 2. And we'd have half of x plus 2 pi. Remember that half number is based on the frequency, and we've got our shift to the left, and so that indicates we'd have x plus, not x minus 2 pi.